Hello students, in this video we are going to discuss the important topics of chemistry, that is metals and non-metals. Okay, we'll try to cover each and every concepts. So please watch the video till the end and share with your friends if you like the video. Okay, so I'm going to discuss every concepts of this chapter in one short, children. Okay, so please stay with me another 10 to 15 minutes. See, generally metals are elements which conduct heat and electricity. Yes or no? I hope you know these concepts of metals. Okay, so see, these are the property, children. Metals are generally hard. Okay, state generally they are found in solid states, except mercury, which is in liquid state. Yes or no? They are sonorous, they produce sounds. Okay, they are good conductor of heat and electricity. They are malleable, that is, they can be beaten into thin sheets. They are ductile, means they can be drawn into thin wires. Generally, they are having high melting and boiling points. Yes or no? They are having high density. Okay. Most of the metals are gray in color. Okay. But gold and copper are what are exceptions. Next, children. Talk about the chemical property, which is very, very important. Okay. First is what are reactions with oxygen. So most of the metals form respective metal oxides when react with oxygen. So metal plus oxygen gives you what? Metal oxide. You can just note on this one. Metal plus oxygen gives you metal oxide. For example, potassium and sodium, they will give you potassium oxide and sodium oxide respectively. See, potassium and sodium are highly reactive. It is highly exothermic. Okay, the reaction is highly exothermic, so it can catch fire also. Okay, see, why it is K2O? Try to understand. Potassium valency is 1, oxygen valency is 2. So by crisscross method, K2O. Yes or no? Similarly, is NO2 only. Na2O. Yes or no? Next. Reaction with the reaction with the reaction of copper with oxygen. Copper react with oxygen, give you what? Black coating of copper oxide. Remember one thing. Okay. Whereas silver, gold, and platinum do not react with oxygen. Next, second equation. Reaction of metal with water. Generally, children, metal react with water, give you what? Metal hydroxide plus hydrogen. Very, very important. Okay. So it depends upon the reactivity of metals actually. So in which form of water they will react, whether they will react with cold water, hot water, or a steam. For example, see, sodium and calcium react with the cold water only. See, sodium react with cold water, give you what? Sodium hydroxide plus hydrogen. Calcium react with cold water, give you what? Calcium hydroxide plus hydrogen. Whereas magnesium react with the hot water only, give you what? Magnesium hydroxide plus hydrogen. Is it clear? Okay. What happens, children? They may ask you, what will happen when magnesium react with steam? They will react with the steam. It gives you what? Magnesium oxide, children, plus hydrogen. In this case, hydroxide is not formed, just a steam. With the steam, it is forming magnesium oxide. You can read the statement, children. I am giving the explanations. Okay. Next, reaction of aluminum with water. In which state of water aluminum reactor? It will react with the which form? Steam form only. Aluminum react with the steam, it gives you what? Aluminum oxide plus hydrogen. Is it clear? Similarly, zinc also will react with the steam only. Okay. So zinc react with the steam, it will give you what? Zinc oxide plus hydrogen. Iron also react with the steam only, give you what? Iron oxide, Fe2O3 plus hydrogen. Is it clear? Next. Here only it is given. Reaction of iron with steam, it gives you what? Fe3O4 plus hydrogen. Okay. Is it clear? One more question is there, children. Both calcium and magnesium, okay, are heavier than water, but still float over it. Why? Important questions. See here. Both calcium and magnesium float over water surface because hydrogen gas is evolved when these metals react with water. It is the form of bubbles which stick the metal surface. Therefore, they float over it. For example, calcium react with water. We got calcium hydroxide plus hydrogen. So what will happen, children? The calcium magnesium will stick to the bubbles of hydrogen. Is it clear? That's why they float. So other metals usually do not react with water, okay, or react very slowly. Okay, yes or no? For example, you can see here. One second. For example, okay, lead, copper, and silver and gold do not react with steam also. Okay, so here reactivity series is also there, which is very, very important. You should remember what is reactivity series. It is the arrangement of elements in the decreasing order of their reactivity. For example, potassium, sodium, sorry, this is a potassium, sodium, calcium, magnesium, aluminum, Al, okay, zinc, iron, lead, copper, silver, gold and platinum. Platinum is least reactive and potassium is most reactive. Is it clear? Next, third type of reaction is the reaction of metal with dilute acid. Remember this sentence, children. Generally, metal react with dilute acid. Give you what? Salt plus hydrogen. Yes or no? For example, see, sodium plus HCl. Give you what? Sodium chloride plus hydrogen. Yes or no? Next, magnesium plus hydrochloric acid. Give you what? Magnesium chloride plus hydrogen. Yes or no? Next, zinc plus sulfuric acid. Give you what? Zinc sulfate plus hydrogen. Yes or no? Okay. See, children, hydrogen gas, this is also very, very important. Hydrogen gas is not evolved when metal is treated with nitric acid. Try to understand. Nitric acid is very good oxidizing agent. So it will convert the hydrogen into water. That's why it is not giving the hydrogen. Is it clear? That you have to remember, children. You can read this sentence to write, okay, to elaborate your answers. Okay. Next, children. So note the properties of metal oxide, children. Okay. Metal oxides are generally what? These are basic in nature. Why? Because metallic oxide react with water, give you what? Hydroxide. Like Na2O plus H2O give you what? 2NaOH. Yes or no? Okay. Next, potassium oxide plus hydrogen plus water give you what? Potassium hydroxide. Yes or no? Next, zinc oxide and aluminum oxide. Here, children, zinc oxide is water and aluminum oxide is amphoteric in nature. Why? Because they can react with acid as well as base. You should know, children, generally acid react with a base to form salt and water. So here you see zinc oxide is reacting with NaOH, giving what? Sodium zincate, Na2 ZnO2 plus water. In this case, second equation, zinc oxide react with hydrochloric acid, gives you what? Zinc chloride plus water. Here, whenever it is reacting with sodium hydroxide, so here zinc oxide is acting as a acid. Here this is salt, this is water. Yes or no? But wherever it is reacting with HCl, zinc oxide is acting as a base. So same substance acting as a base as well as acid. Okay, the acid here in this case acid, in this case base. So such substances which we have such acid as well as base are called as amphoteric. Same is with the aluminum also. Okay, you can see here aluminum oxide reacting with the base NaOH give you what? NaAlO2, sodium meta-aluminate we can say, or aluminate plus water. Okay, here aluminum oxide is reacting with NaOH, so Al2O3 is acting as a acid. In the second equation, Al2O3 reacting with HCl. So Al2O3 acting as a base. It will form water, salt plus water, AlCl3 plus H2O. Is it clear? Now reactivity series I told you just now discuss. Okay, order of decreasing reactivity of the metals. Once again, you can see this. Okay, here K for potassium, Na for sodium, Ca for calcium, Mg magnesium. So from top to bottom, reactivity decreases, children. Okay. So potassium is most reactive, then sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen. Okay. Copper, mercury, Hg, mercury, Ag, silver, and Au, gold. Yes or no? Next, reaction of metal with a solution of other metal. This is a displacement reaction we have discussed in this first chapter also. Generally, a more reactive metal displaces a less reactive metal from its salt solution. Here see metal A react with the salt of metal B. You see what? Salt of A plus B. What is the condition? Metal A must be more reactive than B. For example, iron react with copper sulfate. Give you what? Iron sulfate plus copper. Yes or no? Aluminum react with copper sulfate. Aluminum sulfate plus copper. As aluminum is more reactive than copper. See zinc plus copper sulfate. Give you what? Zinc sulfate plus copper. Why? Because zinc is more reactive than copper. Is yes or no? Okay. Next, children. Copper plus AgNO3. Is it possible? Copper is less reactive. Yes or no? So it is not possible, children. But when copper is dipped in the solution of silver, yeah, copper is more reactive than silver, correct only. So when copper is dipped in the solution of silver nitrate, it displaces the silver. Yes. Why? See here, children, you see the reactivity series. You see the reactivity series. Here, where is the copper here? Okay, where is the silver here? Yes or no? So this element which is above, okay, is a more reactive. So copper is more reactive than silver, so it will displace the silver from the solution. Yes or no? So copper nitrate plus silver is formed. Very, very important. Remember this one. Okay. Next. Is it possible, children? Ag plus CuSO4? No, not possible. Why? Because silver is what? Less reactive than copper. Gold plus copper sulfate. Is it possible? No. Why? Because gold is what? Less reactive than copper. That's why no reaction. Is it clear? Okay. Aluminum nitrate plus copper. Is it possible? No. Because copper is less reactive than aluminum. No reaction. So no. Now coming to the non-metals. Non-metals they will show the opposite properties of that of the metal. So like generally they are soft, children. Okay, there are a few examples which are hard like a diamond. Okay, state they may exist as solid, liquid, and gaseous state also. They are generally non-lustrous. They are generally non-sonorous. Yes or no? But exceptions are there like a diamond and iodine are exceptions, they are lesserous. Okay, they are generally non-sonorous. Okay, is it clear? Okay, next coming to the chemical properties of non-metals. Reaction of non-metals here with the first oxygen. Non-metal react with oxygen give you non-metallic oxide like C plus O2 gives you water, CO2 plus H2O. C plus O2, okay, in the absence or very limited supply of oxygen, it gives you what? Carbon monoxide, children, plus heater. Sulfur plus oxygen, sulfur dioxide. Yes or no? So non-metal react with oxygen give you what? Non-metallic oxides. Hydrogen plus oxygen give you what? Water actually. Okay. See, what is the nature of non-metallic oxide, children? Generally, they are acidic in nature. Remember, why? Because this non-metallic oxide react with water, give you what? Acid. CO2 plus H2O give what? H2CO3. SO2 plus H2O, H2SO3, sulfurous acid. SO2 plus O2, SO3 actually, and SO3 react with H2O, give you what? Sulfuric acid, H2SO4. Yes or no? Next, reaction of non-metal with chlorine. Yes, hydrogen react with chlorine, give you what? HCl. Phosphorus react with chlorine, give you what? PCl3, phosphorus trichloride. Reaction of non-metal with metal, okay, or reaction of metal with non-metal, very, very important. They will form a ionic bond. How they are forming? Ionic compound actually they are. Remember, very, very important, most important topic of this chapter. Many metals, okay, form ionic bond when they react with non-metals. So ions, two types are there. Positively charged ions are called as cations. Negatively charged ions are called as anion. What happens, children? Sodium is atomic number is 11. Okay, to become a stable, it loses one electron, right? 2, 8, 1 is there. So it loses one electron, become Na plus. Magnesium similarly, it will form ions. Which kind of ions? Cations. Magnesium atomic number is what? 12. 2, 8, 2. To become a stable form, it will lose 2 electrons, form Mg2 plus ion. Yes or no? I will show you the dot structures. You can see. Similarly, chlorine atomic number is what? 17. 2, 8, 7. To become a stable, it will gain 1 electron, become Cl minus ion. Yes or no? So what is ionic bond? The bond which is formed by between the metals and non-metals by the transfer of electron. By the transfer of electron. You can see here. Formation of NaCl. They will ask you the dot structure, children. In the dot structure, we are showing the how the electrons are shared. See, sodium valence electron is here. Already what I explained is written here. Atomic number of sodium is what? 11, 2, 8, 1 electronic configuration. Okay, valence electron is what? 1. Now, chlorine is what? 17, atomic number 2, 8, 7. So, what is the valence electron? 7. So, here sodium 1 valence electron is there, chlorine 7 valence electron is there, 2, 2, 4, 2, 6, and 1, 7. So, 1 electron is transferred from sodium to chlorine, form Na plus and Cl minus ion. Yes or no? In this case, NaCl is formed. Okay, similarly, we can show for MgCl2 also. Okay, you should know the important properties of ionic compounds, children. Okay, like they are generally solid, they are generally brittle, they are having high melting and boiling point. Why? They will ask you because of a strong force of attraction. Okay, yes or no? Because force of attraction between the ions of ionic compounds are very strong. Ionic compounds are generally soluble in water. They are insoluble in organic solvents such as kerosene, petrol. Ionic compounds do not conduct electricity in solid state, but they conduct electricity in the molten or aqueous state. Why they will conduct? Because of the free ions. Yes or no? And the last topic of this chapter is what, children? An extraction of metal. Okay. No, occurrence of metal. That is studied under metallurgy, children. What is metallurgy? Metallurgy is the method of extracting metal from the ore. Yes or no? So here some terms are there, children. You should know. You can read these concepts. I'm explaining in common words, very short words. What are minerals actually? Minerals are the naturally occurring inorganic substances. What is ore? An ore is a mineral from which a metal can be extracted economically or conveniently. Yes or no? For example, iron ore is there, hematite. And aluminum ore is what? Bauxite. Okay, similarly copper pyrite. Yes or no? Here. There are some other terms like a gangue. Gangue is what? Impurities present in the ore. To remove the impurities, we are adding some substance that is called as flux, children. Whenever gangue and flux combine, they will form unwanted material that is called as slag. These are the terms also you should know. Is it clear? Now let's talk about the flow chart. See, children, to get the metal from the ore, we have some method which we are following. First is what? Concentration of ore. Second one is what? Conversion of concentrated ore into oxide. Okay, and third one is what? Reduction of metal oxide into metal, and fourth one is what? Refining of metal. Here it is, three only step is there. Okay, just focus here. Flow chart is very, very important. Sometimes they are asking in the direct question in the board exam, 3 marks. So we have 3 types of metals actually. A concentration for all the types of metal, we will do the concentration of ore. Yes or no? Concentration means here basic impurities are removed. Okay, here different methods are there, like froth flotation method, hydraulic washing, and magnetic separation is there, then leaching is there. So we'll study in higher standard. Okay, just you should know the what are the methods of concentration. Okay, next, concentration of ores. We are after doing the concentration of each type of ores actually. Okay, we have three types of metal actually: high reactivity, medium reactivity, and low reactivity. When we talk about high reactivity, we have to do the electrolysis of molten ore. We'll get the pure metal. If it is of medium reactivity, we just two forms are there. Okay, two forms of ores are there, that is carbonate ore. For carbonate ore we'll use calcination. For sulfide ores we'll use roasting. Okay, in calcination what happens, we'll discuss in detail also. Okay, it is heated, ore is heated strongly in the absence of air, we'll get a metal oxide. In roasting, the sulfide ores are heated strongly in the presence of air, we'll get a metal oxide. Okay, and after that we'll reduction of metal, and then reduction of metal will do get reduction to metal, and after that purification of metal. If it is of low reactivity, children, it is generally in the form of sulfide ores. Okay, so we'll do the roasting, we'll get the metal, and we'll do the refining. Yes or no? So here they have given in steps concentration of ore. You can read about the concentration. So removal of impurities. Yes or no? Okay. Next, conversion of concentrate ore into oxide. So this is most important, children. We are following two methods. One is water roasting and other is calcination. In roasting, what happens? Heating of sulfide ores in the presence of excess of air to convert them into oxide is called as roasting. So for example, zinc sulfide react with oxygen, give you what? Zinc oxide plus sulfur dioxide. What is calcination? Heating of carbonate ores in the limited supply of air to convert them into oxide. So zinc carbonate react with the, okay, not react, it is heated strongly in the absence of air. Give you what? Zinc oxide plus carbon dioxide. Yes or no? Here is difference is the given, children, in the table. You can read this one. Calcination and roasting. Very important 3 marks question expected for the board exam. It is done for the carbonate ores, calcination. Roasting, it is done for the sulfide ores. Yes or no? Calcination, carbonates or ores are heated in the absence of air. Okay, here sulfide ores are heated in the presence of air. Here in the calcination, the CO2 gas is released and metal oxides is obtained. Like zinc carbonate heated, give you zinc oxide plus carbon dioxide. Here sulfur dioxide gas is released and metal oxide is obtained. Like zinc sulfide plus oxygen give you what? Zinc oxide plus sulfur dioxide. Yes or no? Next, reduction. So reduction, we are using a reduction of metal oxide into metal actually, children. We are using reducing agent or self reduction. Okay, for example, if you see sometimes a sulfide ore is there. So we are hitting with the oxygen, give you what? Metal oxide. If you hit a metal oxide, okay, like a mercuric oxide, you will get pure metal. Yes or no? How will get the extraction of copper metal? Very, very important. This is also 3 marks question they can ask. So copper ore is what? A copper pyrite. We'll go the roasting. We'll do the roasting. So we'll get a metal oxide actually plus sulfur dioxide. Okay, now what happens? This is here wrong actually. Cu2O will come. Now Cu2O will react with the ore itself. Will give you pure copper or copper plus sulfur dioxide. Here what will happen? This is called as self reduction, because to convert copper oxide into copper, we are using the ore itself. Yes or no? Now extraction of metal with the medium reactivity, like here you see, they may ask you at the procedure for extraction of zinc ore. So zinc is what? Zinc sulfide, zinc blend. React with, we'll do the roasting, we'll get the zinc oxide. Now if it is carbonate ore, we'll use the calcination, we'll get zinc oxide. Yes or no? Now what will happen? Zinc oxide is converted into zinc with the help of coke or carbon reducing agent. Yes or no? So zinc oxide plus coke give you what? Zinc plus carbon monoxide. I hope you are understanding this, children. Okay, if you're not understanding, you can watch my short videos also, topic wise I explained. Okay. Okay, next, extraction of iron. So iron is what? Hematite, Fe2O3. So we are hitting with coke actually. You will get iron. Yes or no? Extraction of lead oxide is there. So you are hitting with coke. If you get, we'll get a lead. Yes or no? Manganese oxide. Manganese oxide, we are hitting with aluminum. Aluminum is more reactive than manganese. Yes or no? So displacement reaction. Copper oxide reacting with aluminum. Give what? Aluminum. Copper plus aluminum oxide. These are thermite reaction actually, we can say. Okay, thermite reaction, okay, is a reaction of iron oxide with aluminum. Aluminum, as it is more reactive, so it will displace the iron. In this reaction, what happens, children? A huge amount of heat is released, highly exothermic reaction. So iron we are getting in the molten state actually. Is it clear? Next, what about the extraction of metal of high reactivity? Okay, high reactivity, we are doing the electrolytic reduction. For example, sodium chloride. So we just pass electric current. Okay, so we'll get Na plus ion and Cl minus ion. So at anode and cathode, Na plus will at cathode it will undergo what? Reduction. It will gain the electron, become sodium. and at anode, which is positively charged electrode, it will lose the electron, becomes Cl2 gas. Yes or no? So NaCl will give you Na plus Cl2. The last procedure is what? Refining or purification of metal, which is very, very important. Here what happens, suppose let's take example of copper, children. Here what we are doing, we are taking a two metal. Okay, one metal which has to be purified, like impure copper here as a cathode, and a strip of pure copper as anode. Okay, so sorry, 1 second, children. Impure copper, actually impure copper is what? Anode, actually. Okay, and a strip of pure copper is what? Cathode. So cathode, pure copper here connected to the negative, and impure copper is connected to the positive. Yes or no? So what happens, at anode oxidation will happen, and at cathode reduction will happen. Oxidation means loss of electron. You can see here equations are there. So copper will lose the 2 electrons at a anode oxidation. Yes or no? So copper will lose the 2 electron, becomes U2 plus ion. Okay, and at anode, okay, reduction will happen. Reduction means gain of electron. So Cu2 plus ion will gain the 2 electron, become copper. Yes or no? So in this way, what happens, all the impure copper will first dissolve into the solution, and from the solution, the pure copper ions will get deposited here. So here impurities are settled down at the bottom as anode mud. Yes or no? And the last topic is what? Corrosion, children. Okay, corrosion is nothing but the process of destruction of metal surface whenever it is exposed to moisture, air, acid, bases, salts. Yes or no? So we have rusting of iron, like iron react with oxygen and water, give what? Hydrated ferric oxide. Now, brown layer is obtained. Rusting of copper is also there. Now, basic copper carbonate is formed. Okay, CuOH twice dot CuSO3, and silver will form black coating, Ag2S. Yes or no? So to prevent the rusting, we are having some procedures, children. Some methods are there, like painting, okay, greasing, galvanization, electroplating, and alloying. Okay. So what is alloy? Alloys are the homogeneous mixture of two or more metals, or metal with a non-metal. Like example, you can see amalgams, an alloy of a alloy in which the mercury is present. For example, sodium amalgam, Na and mercury. Okay. Ferrous alloys are there, alloy in which iron is present. For example, manganese steel. Iron 86%, manganese 13%, carbon 1%. So no. So properties of alloys are stronger than metal. Okay, from which they are obtained. It is harder than the constituent metal. They are more resistant to corrosion. Okay, yes or no? The melting point is lower than the constituent metal. These are the properties. Brass is what, children? 80% of copper and 20% of zinc. Bronze is what? 90% copper and 20% tin. Bronze, copper and tin. Solder, lead and tin, 50-50%. Okay, duralium, aluminum, copper and manganese. Yes or no? Percentage that much not important. Okay, you should know about the 24 karat gold. Okay, 24 karat gold is 100% pure gold. Yes or no? And 18 karat gold means 18 part of gold and 6 part of copper or silver. Yes or no? Here you can see the tables of difference between metals and non-metals. Okay, children, this is the way. Okay, you can do the fast revisions. If you have understood this concept, children, please share with your friends and subscribe the channel. Thank you.